We're given the velocity as a cubic that's been factorized, and we're also shown the graph. Now that does allow you to straight away write on that this is 3, this is 0, and there would be a root later on at 8. It would come back down, or in fact it's probably closer to the left, but yeah, it's there. Now, we're told that p attains its maximum velocity at time t seconds. That's indicated, and the diagram shows parts of the graph state the acceleration of p at time t. So this is when essentially there's a stationary point. dv by dt is going to equal 0. But dv by dt is the acceleration. When you hit a maximum speed, there is no acceleration for an instant. So the answer is that a is equal to 0. We're asked to show detailed reasoning for this next part. We're asked to determine the value of t. So for this, I'm going to actually need to differentiate v and then set it equal to 0. So v is going to be t times, this is a slightly awkward one, I'm going to get 8t minus t squared minus 24 plus 3t. I just tidied that up for a second. I'm going to put it in order actually of the powers. So minus t squared plus 11t minus 24. So I get minus t cubed plus 11t squared minus 24t. Okay, next let's differentiate it. So it's going to give minus 3t squared, bringing the power down, and subtracting 1 plus 22t minus 24. And this is going to equal 0 at stationary points. Okay, so they've asked for detailed reasoning, so I can't just stick this in my calculator. I'm expecting it to factorize. First up, I'm going to make it so the 3 is positive, so basically swap all the signs around. Now, if it's going to factorize, and it's got to, I think, it's going to be 3t and t, and then we're trying to make it work with two numbers to multiply to give 24, and they're going to combine to give minus 22. They're going to have to both be negative to get the positive when you're timesing, but the negative when you are adding, not adding them, but combining and adding. Notice both of them are even, so you could try 8 and 3, for example, but that will end up with an odd number. So 6 and 4 are maybe the best way to go. So let's say, for example, I put 6 here and 4 here. Then I would get minus 12t and minus 6t. So that's not enough. So what if we swapped it around to 4 and 6? Now I'm going to get minus 18t and minus 4t. Okay, that's the one. We can stick that in. So t is going to equal 4 over 3 or 6. And looking at the graph, we can see the first stationary point is going to be the 4 over 3, and t is the second one, t is going to be 6. We don't need to show that it is a maximum or anything, like just looking at the graph is enough and justifying it, I think. Then in part C, we're asked to find the total distance that p travels between 0 and, in our case, 6. I mean, like, just be a bit careful here. What you should not do is integrate from 0 to 6, because the problem is if you integrate from 0 to 6, this bit will be negative and this bit will be positive. So what you will find is the total displacement, but it will, incorporate the fact that we are going to the left and then going to the right. It won't actually add positives on for going to the left. So we need to separate it into two integrals. First up, I'm going to find the displacement between 0 and 3. Now actually, I can use, this is only a 3-mark question. It doesn't say I have to show detailed reasoning here. I can just put it in my calculator as a triple bracket. course, you should be able to do it without your calculator, but in this kind of question, you've also got to know when to use your calculator and when not to, especially to save time, get onto the later questions. Um, okay, so I'm in integration mode now. Place everything by x, but it's the same sort of thing. Okay, minus 117.4 or minus 29.25. And same again from 3 to 6, same integral. You can just press right, actually it's left, sorry, left and then delete, left, delete, which gives 65.25. So overall, the total distance is going to be 29.25 plus 65.25. We can do this without a calculator. It's probably best to be careful though. So 65.25 plus 29.25 gives 94.5 meters.